Alright, today we are tackling a mathematical puzzle that pops up just about everywhere, from engineering to, your final exams. We are talking about polynomials. You know that feeling, right? You look at an equation and it just looks like a jumble of letters and numbers, a secret message you're supposed to decipher. Well, if you've ever felt that way, you are definitely not alone, and that's exactly what we are going to fix. Because what you're looking at right now, that's not some impossible code. It's a polynomial. And I promise you, by the end of this, you're going to have the keys to unlock any problem that looks just like it. So let's start by decoding the language. Okay, first things first. 1 in the world is a polynomial, really. Let's just break it down. So, in simple terms, a polynomial is just an expression with a few key ingredients. You know, something like 3x squared plus 2x minus 5. It's basically a mix of constants. Those are just the numbers and variables, like our x here, that are raised to a power. Now, there's one really important rule. Those powers have to be non-negative, so you can't have x to the power of -2, for example. That's a no-go. So, every single polynomial is built from these 3 little blocks. The terms are just the individual chunks separated by a plus or a minus. Coefficients are the numbers writing shotgun with the variables, like the 3 and 3x squared. And the degree? That's just the biggest, baddest exponent you can find in the whole expression. And trust me, that one little number tells you a ton about how that polynomial is going to behave. Alright, now that we speak the language, let's open up our toolkit. These are the absolute game changers, the rules that turn a messy, complicated problem into something totally manageable. Okay, now these two, think of them as a dynamic duo. The remainder theorem is your ultimate shortcut. It lets you find the leftover from a division problem without, actually doing the long division. You just plug in a number. And the factor theorem is its awesome sidekick. If that remainder you just found happens to be 0, well, you've hit the jackpot. That means you found a perfect factor of the polynomial. They work hand in hand. And this whole process is what we call factorization. It's kind of an art form, really. All we're doing is breaking a big, clunky polynomial down into smaller pieces that are multiplied together. For an equation like this one, it's a fun little puzzle. What two numbers multiply to get the last number, 6, but add up to the middle one, -5? In this case, it's -2 and -3. And just like that, we've turned one complicated thing into two much simpler ones. Okay, theory is great and all. But let's see how this stuff actually performs under pressure. We are going to jump into some real questions from exams like JAMB and WAEC, and see how these tools give you a serious advantage. So here's a classic exam question. They're nice enough to give you one factor, x minus 2, and they just want you to find another one. Now you could use long division, but in a timed exam, that's just asking for trouble. It's slow and it's easy to make a small mistake. Lucky for us, there's a much faster way. And that secret weapon is called synthetic division. Seriously, this method is so clean, so fast. It's the kind of thing that saves you precious minutes when that clock on the wall is ticking down. Okay, here's how it works. It's actually pretty slick. First, you just write down the coefficients from your polynomial, 1, -3, -4, and 12. Since the factor is x minus 2, the number we are going to use is 2. Now just follow the pattern. You bring down that first number, you multiply, you add, you multiply, you add, and what's that last number? It's 0. That's the proof we need. It confirms x minus 2 is a factor. And the numbers left over, they actually give you the other factor. It's that easy. Alright, let's pivot to a different type of question you might see on the wasted exam. This time, they don't care about the factors, they just want to know, what's the remainder? And again, long division is an option, but we've got a much smarter tool for this job. Remember our friend, the remainder theorem. This is its moment to shine. The question asks for the remainder when we divide by x minus 1, so that means our magic number is just 1. So all we have to do, literally all we do, is plug 1 in for x everywhere we see it in the polynomial. No messy division, no complicated steps, just simple arithmetic. So you plug it in, you do the math, 2 minus 3 plus 1 minus 1, and you get your answer. The remainder is -1, boom, done. See? That's the power of knowing which tool to pull out of your toolkit. Look, knowing the math is one thing, but being able to perform on exam day is a whole different ballgame. So let's lock in some pro tips, some real strategies for the challenges you're actually going to face. And these aren't just random tips, they're based on how each exam is designed. For WAEC, don't get tempted to start cancelling things out early, factorize everything completely first. For JAMB, it's a race against time, so you need to get so good at synthetic division, it feels like muscle memory. And for NECO, take 5 extra seconds to plug your answer back into the equation. It's a simple double check that can save you from a costly mistake. And if you're worried about remembering all this under pressure, here's a little trick. When you see a question asking for the remainder, just think, plug and play. That's it. That's your mental trigger, to just substitute the value and completely skip all that long division nonsense. So let's just take a step back and look at our journey. We started with something that looked like a scary secret code, and we found out it's actually just a logical puzzle. And honestly, that's the biggest takeaway here. Polynomials aren't designed to trick you, they follow clear, predictable rules. And once you've got tools like the factor theorem and synthetic division in your back pocket, you have everything you need to walk into that exam and solve these problems with total confidence. The keys we've talked about today, they're not just about passing a math test, they're about learning how to look at a complex problem and break it down into simple parts. So the real question is, now that you have the keys, what's the next puzzle you're ready to solve? Solve these questions and check out www.examkp.com for the answers. Number 1. The polynomial f(x) equals 2x to power 3 plus px plus qx, 5 has x1 as a factor and a remainder of 27 when divided by x plus 2, where p and q are constants. Find the values of p and q. Number 2. If 2x squared kx, 12 is divisible by x4, find the value of k. Number 3. A polynomial in x whose roots are 4/3 and -3/5 is